Okay, for question number 39, it's given that for optical instruments, they consist of a number of lenses and they are combined to increase the magnification and sharpness of the image. So that means these lenses are combined like this, they are placed like this, so that the effective lens formed by these combination will have the power of sum of the lens. So they are placed in contact and their power is given by the algebraic sum. That is, if we add the sum of the individual sum of, if we add the powers of the individual lenses, it will give us the sum of that, the effective lens formed. And these are widely used to design lens system of cameras, microscopes, and telescopes. Now, this lens system can have, so this is a lens system, it can have a combination of convex as well as concave lenses. So if convex lens of power 4D and concave lens of power minus 2D are combined, what should be the nature of the combination of the lens? So that means our first power is 4D and the second lens has power 2D. And we know that power is added. So this is P1 plus P2 power of the lens first. So this is 4D plus minus 2D, which gives 2D. So this has plus as the symbol for the power. So that means it is a convex lens, it is a convergent lens. So the combination is a convergent lens because plus power is for the convex lens, convergent lens. Now, next is to calculate the focal length of a lens of power negative 2.1. So power negative 2 the power of the lens in meters. So this is negative 2.5 D is 1 upon 2.5 to negative 100 by 25, which is equal to negative 4. Okay, so this is our, so this is negative 10 by 25. This is 5 2. This is negative 0.4 meter. And if we have to write this in centimeters, so I can write it as this is 40 centimeter, negative 40 centimeter is the focal length. Okay, now moving on to the next part. Now we have to draw a ray diagram to show the nature and position of an image formed by a convex lens of power point D. So this is the convex lens of the power point D. Let's find its focal length first. So the focal length in meter, we know that power is 1 by f, where focal length is in meter, this is 0.1. So that means focal length in meter is 1 upon 0.1, which gives me 10. This is 10 meter, which is zero point 0.1 centimeter. Or let me just keep it as 10 meter. So 10 meter is the focal length. And now, formed by convex lens of power point D, and when an object is placed at a distance of 20 centimeter from its optical center, so that means it's a convex lens, and object is placed at 20 centimeter, so the focal length is 10 meter, and okay, so there is a convex lens, and let this be the optical sector. This be the first principal focus. This is now the object is placed between it is placed at distance of 20 centimeters. So that means the focal length is 10 meters between optical sector and the focal length. So this is where the object is placed. And we denote subject by AB. Okay. So the first ray of light will go through the first principal focus, and the second ray of light we will take it through optical center, and let's produce them backwards. And if you produce them backwards, so this will intersect here. And because we have assumed them to be, we have extended them backwards, so this we let this be in the dotted lines. So the image formed here is virtual and erect. So this is where the image is formed, which is virtual and erect. It's highly magnified. So this is the image formed. E dash that is beyond the center of curvature. Okay. Okay, so this is the ray diagram. We have drawn the ray diagram to show the nature and position of image formed. So nature of image is virtual and erect, and position is beyond center of curvature. And highly magnified. So it was also only the nature and position of the image formed, or how is a virtual image formed by a convex lens different from that formed by a concave lens. So in a convex lens, when the virtual image is formed, so what is the difference between the virtual image when it's formed in case of a convex lens and when it is formed in case of a concave lens? So in convex lens, when the virtual image is formed, this is magnified. And in concave lens, when the virtual image is formed, this is diminished. And here you see in case of convex, the object is between here, the object is between optical center and focus. So that's the difference. The object is between optical center and the principal focus. So that's the difference. This is the convex lens and this is the concave lens. And in this case, object is magnified, this is diminished. This is object is between optical center and focus, and here the object is anywhere between optical center and infinite. Okay, so this is the difference for virtual image. Convex and concave lens. Let me show you how. Okay, this is the convex lens. Here the object is placed between optical center and principal focus, and this is the magnified image form in case of a convex lens. And in case of a concave lens, this is the image form which is diminished. Here the image is magnified and object is anywhere between infinity and the optical center. We get the virtual image. So it's smaller diminished and it's enlarged, and object is placed between O and F. Here the object is placed anywhere between infinity and optical center. So that's the noticeable difference. Okay, with this, and under what conditions do a convex and a concave lens forms virtual images? So I have given the answer under what conditions opt for concave convex lens object is between O and F, and for the concave lens for virtual images object is between anywhere between infinity and optical center.